It's actually kicked me all the way out of the system, so that's fine. That's because the box is panicked. No. So that was an example of DTrace doing a dynamic tracing. And if I just jump on a system and show you a different one, then that example will be complete. And I'm not going to jump all the way to that anymore. I'll jump to. You are connected. You know, I just think I lost wireless, and it's unhappy for a while. All right. So that example was dynamic because it changed the function. The other static that I can demonstrate later is static tracing, where some places are left behind in code at very interesting places, such as when I/O starts, so that we can have, instead of detracing the raw kernel code, we can detrace something more user-friendly. And what happens is it leaves some knobs behind, and then DTrace can go and change that when it needs to. But I think you get the picture. DTrace will go and change the live kernel code to do what it needs to do. And essentials, terminology. Consumer, probe, and action. I've mentioned them before. Consumer in this case was the DTrace command. That's the probe that I'm tracing and the action that I run. Consumers of libdtrace on Solaris include dtrace, logstat, plogstat, and intrstat. Libdtrace is a private interface, not to be used directly. You don't need to. If you're using dtrace, for most things we prefer you use the library directly, but with dtrace it's fine to do scripting. And the library is actually not a stable API anyway. And I have written to prove the point, I wrote something that was scripted and something that talked directly to libdtrace to performance test them. And there really wasn't much help talking directly to libdtrace because of the way dtrace actually works. It assembles the script that you're doing in its own instruction set, DOF, and then runs that. It doesn't matter if you're a command or a library. If you see something like that, DTrace requires additional privileges, then you need additional privileges like root. Solaris 10 has least privilege. The probes, syscall read entry. So the big thing to understand about probes is the first argument is the provider name. Think of it as a library name. That says syscall. What the other fields mean depends on the first. So for syscall, the other fields will describe the system call. For proc, it's all about process events. For I/O, it's about I/O events. For I/O events in particular, there was a popular script I wrote to look at I/O events. I think I've got it here. I/O snoop. Except, oh no, I need to change that to run on macOS. Oh, wait a minute. Okay. iSnoop's installed already, of course, because Apple decided to install a bunch of, which is fine, to put a bunch of DTrace toolkit scripts with Mac OS X in user bin. Now, I didn't put this here. This came with Mac OS X. What's that?
Did they say thanks?
Yeah, they did say thanks. So. They didn't. No, they did a good job. So, and they made it, and they obviously made it work because their version works and mine doesn't. So, they actually fixed it. So, so cool. So, I/O snoop is that's pretty interesting. That's actually tracing disk I/O, and it's giving me information such as the process ID, the direction, the block, the size, the command, and the path name. This was a pet peeve of mine when I was a system administrator at the University of Newcastle. I wanted to understand who was doing disk I/O, and that was really hard to answer. And so that embarked a journey of learning all sorts of different things and culminated with DTrace, which just makes this problem very easy to solve. So DTrace can snoop or can trace disk I/O and give you all the useful information that you need to know. Why is Windows Server writing to log Windows Server.log? I mean, small writes and it's flushing them, because this is actually disk I/O, okay. Is exec snoop on there? Oh, it is, okay. The exec snoop actually I could have run earlier, man ls, and there you go, it's telling me what was run. That's not giving me arguments? Come on. No. No, that needs some fixing. All right. I haven't played with their versions, but so lots of fun. So I just demonstrated IO snoop, but you can write it yourself. It's a very simple script, and that looks at disk I/O. You can look at syscall I/O or logical I/O at the file system level instead, if you like, because DTrace lets you look at the whole stack. Already explained that. Listing probes, done some demos of that. DTrace -L, and there's lots. Tracing probes, that's what -N does. Providers, there are plenty. And providers, the thing about DTrace, and this is why it's useful to listen to a presentation on DTrace, when you look at other people's scripts, it's easy to DTrace the raw kernel or raw application code because you get access to everything you want. It's not so easy if you're trying to learn DTrace and you look at other people's scripts. If you look at my scripts and I'm DTracing all sorts of private parts of the kernel, because it assumes a lot of kernel knowledge, and the same for user land programs. So while that's possible, there are easier ways to use DTrace, and that's about the providers. So things like syscall, proc, shed, sysinfo, vminfo, they take some of the kernel internals and make it into a much more user-friendly interface for you to use and write scripts on. They're also stable. So if I write scripts that use the stable providers, they'll work forever and they should work on other operating systems as well. If I write a script that DTraces how the kernel allocates memory, and I'm interested in KMEM cache latency or something like that on Solaris, and I use what's called the FBT provider, which is raw kernel tracing. FBT stands for function boundary tracing. If I write that on Solaris, it's probably not going to work on Mac OS X because I've DTraced the raw kernel. So that's why the other ones exist. You get to write stable scripts. It's easier. They're documented. And some example probes for each of them. So in fact, I did BDEV strategy earlier. So FBT, BDEV strategy, block device strategy when I'm asking a block device to do stuff. That's interesting. You can actually DTrace processes. So I might say, show me fopen from libc, trace that. A.out, show me main. I can use profile to actually sample what's happening as well, not just at the time of execution. So providers, check them out. Check out what's available for your OS. Provider documentation, if it's for Solaris, it's docs.sun.com. If you're trying to, see DTrace, I don't just have access to seeing that the probes have fired, I also have access to their arguments. So understanding these properly, for example, let me DTrace, and right. So if I DTrace, so arg2 of a syscall write entry, what's that? If I man write, wrong one. You don't let me do that? Come on. Is it S2 on Mac OS X? Okay, so that's the byte size. So that's why we look up documentation, because you have visibility of all this stuff. So